All right, we'll have this hopefully be the last video. Here it says this rock should be classified as. So over here we have intrusive or extrusive igneous rocks. We know that if we have an igneous rock, we're looking for intergrown crystals of some sort. This is not intergrown crystals. We have sediments or rocks, and these rocks are cemented together by a cement, probably quartz. So what happens is water will get into an area. As the water gets into this area over here, it's going to have minerals in it. And those minerals, when the water evaporates, are left behind and cements it together. Bioclastic, I do not see any living organisms or fossils. So it has to be clastic, which means fragments. These will be the fragments that are put together with these. 32 or 33. Which change would most likely occur if the rock became buried deep within the crust and was subjected to intense heat and pressure but did not melt? The operative word here is not melt. So if we go to the rock cycle, we see that if it melts, it becomes magma and then it becomes an igneous rock. However, in our case, we have heat and pressure, becomes a metamorphic rock. So the question becomes, what's going to happen here? So in this case, we have these large pebbles. These large pebbles are probably not going to recrystallize. However, if I'm going to put them under pressure like this and like this, maybe they get squished and they kind of look like that. So everything in the rock will kind of look like that. And then the smaller things will still cement everything together, but it's going to recrystallize, which means it's going to form perhaps another sort of mineral. Bowen's reaction series. All right, I want everybody to pay very careful attention to this one because we had some strange answers. For the Bowen's reaction series, the first thing we have to understand is that there are different melting points. So over here we could look at different melting points. This is going to be high, and this down here is going to be low. So when the temperature is hot, and as it begins to cool down, olivine becomes a solid first. Then everything down here is a liquid. As it continues going down, then this is going to solidify out. So this is going to then have a medium, and then these two will be solid, and then this one down here will be liquid. So over time, you're getting different types of minerals, and we know quartz, muscovite, potassium feldspar are minerals that are going to be they're going to be in liquid, and then they're going to actually solidify last. However, plagioclase feldspar is different. Plagioclase feldspar is going to be continue solidifying out at different temperatures, but that plagioclase is going to be more calcium rich when it's hot, and then as it begins to cool, a lot of the calcium ends up solidifying and you have more sodium left over. So that's why plagioclase feldspar is continuous but discontinuous over here. All right. How is chemical composition of plagioclase found in basaltic different than the chemical composition in granite? Well, we just saw. When we have granite over here, it's going to be more sodium rich. Basalt, more calcium rich. Describe the temperature conditions of the Bowen's reaction series that explain why olivine and quartz are not usually found in the same igneous rock type. It's because they have different melting points. Identify one similarity and one difference between igneous rocks, andesite, and diorite. So some people did not look at the ESRT. Remember that you could always look at the ESRT to get this answer. So you're going to look at the igneous rock chart, and you're going to look for, I think it's andesite. So andesite and diorite, if you go down, they all have similar color, similar density, similar composition, pretty much in between. All right. from your felsic and your mafic rocks. However, what are some differences? Diorite is intrusive, andesite is extrusive. Or diorite has large crystals, andesite has small crystals, because we can go over here and it says less than a millimeter or 1 to 10 millimeters. All right, in your answer booklet, at what location is the rock sample collected? So you're going to go up here, and it actually tells you the location, 42. It's 42 and 15, I think. And then we have 42 degrees north, 78 and 15 minutes. So we go down here. We go to 42. So bearing with the line, that's 42. Then we have 76, 77, 78. Now, we know it's 15 minutes. So between here and here is 60 minutes. Right? 60 minutes. So if it's 60 minutes, I know this is 78. It's got to be somewhere around here, because it's 78 and 15 minutes. Next one. Based on the fossils present, the rock sample shown in the diagram came from which rock unit? So if you look at Canada Way, Canada Way has all 4, 1, 2, 3, and 4 rock types. And this one has 1, 4, 1, 3, and 2. So the only one that matches is going to be Canada Way, because it has all 4. Figure 8. Identify the New York State Index fossil that includes fossil 4 shown on the rock. All right, so if you go here, we could do this later because we haven't covered this in class yet. However, if you go to rock 4 is this one. If you go to your ESRT, you're going to try to look for that one. So if you go down here, this is down here. You can't see. Let me move that out of the way. This one is Z. So you could put that name there. Good? All right. Next. Identify the landmass that collided with the eastern coast of North America to create the Acadian mountain range. All right, so ESRT tells us this is the Acadian orogeny, Blizzard of North America, and Avalon. All right, so make sure that you go over this, read everything in here, so that you're kind of familiar and you're not fumbling around during the test. According to the tables, which marine environment was Tully Rock deposited? All right. So we have limestones, because we know limestones are made up of lots of different sediment, lots of different biotic creatures, so it's going to be clear shallow water. Last one, ladies and gentlemen, last set. All right, so it says map 2 shows the course of the Allegheny River during a specific part. What is the time period? All right, map 2 specifically says 22,000 years ago. I go to my ESRT and I go to excuse me a second. All right, time period for 22,000 years ago. So this is the period, and that period covers 1.8 million years to the present. So every period is broken down into epochs. So the quaternary period would have 22,000 years ago. Explain why the divergent direction of the Allegheny River changed. So we know over here the river flowed this way and it had no obstructions. However, this area here is a big ice sheet. So we had a glacier come down. Remember, these glaciers can be miles deep. So it is a big ice sheet. If a river is coming up here, it is not going to go up over the top of the ice sheet. It's going to have to be diverted. It's going to be diverted down. All right. So that's why it's blocked here. And then present day. We know that a glacier leaves behind sediments, and the sediments that it leaves behind are going to be like this stuff. And sediments are called moraines. Oh, and look, it says moraine. Isn't that silly? All right. Look here, ladies and gentlemen. We got some strange answers on this one. You have to do a U-shaped valley. You don't put a V. You don't put a V. All right. Some people put strange things. Whatever it is, you're just going to do straight U, and then you're okay. All right, ladies and gentlemen. I hope this helped. Please email me with any questions. Thank you.